Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 2nd, 2025, just yesterday. The standout result is a simple wide scaling recipe that reaches 69.9% success on OSWorld at 100 steps, surpassing prior work and approaching human-level performance at 72%. The paper is titled, The Unreasonable Effectiveness of Scaling Agents for Computer Use. And as we'll see later, the gains are striking. Beyond the headline number, the work turns raw trajectories into concise behavior narratives and uses a comparative judge to pick the best rollout, while an upgraded Agent S3 cuts time and model calls and shows strong transfer to WindowsAgentArena and AndroidWorld. That headline result set the stage, and Figure 1 puts the comparison in context. The bar chart shows success rates on OSWorld at 100 steps, with a dashed line marking human level at about 72%. Our method reaches 69.9%, which nearly matches humans and exceeds the previous state-of-the-art at 59.9%. Baselines trail further back, from about 30% for OpenAI CUA to roughly 49% for Agent S2. So Figure 2 illustrates why wide scaling helps. The grid shows 3 independent agent rollouts with largely disjoint wins, which means each agent solves a different subset of tasks and fails on others. The top 3 rows depict these complementary successes at about 62% each. The bottom row aggregates by selecting the best trajectory, labeled bBoN, which lifts the overall rate to about 66% because complementary wins are combined. So, Figure 2 highlighted complementary wins across separate runs. Figure 3 shows how wide scaling becomes practical. Multiple trajectories feed a behavior narrative generator that annotates the before screenshot, highlights the after screenshot with a box region, and adds a zoom crop so a vision language model can extract step facts. Those facts form concise narratives. A comparative judge then selects the best trajectory by citing relevant facts, which makes selection robust because the judge focuses on verified action effects. Alright, Figure 3 established the pipeline. Table 1 reports the headline numbers. The table summarizes OSWorld success rates at 50 and 100 steps, showing that Agent S3 already sets a strong baseline at about 63% for 50 steps and 63% for 100 with GPT-5. Behavior best of N then pushes further, reaching about 64% at 50 steps and 70% at 100 with GPT-5, while the mini-model lands near 60%. Table 1 set the headline gains. Figure 4 shows how those gains scale with more rollouts. The curves rise as N increases, which means wider exploration generally boosts success. GPT-5 climbs from about 65% at 2 rollouts to around 70% at 10, with a small dip at 6 that recovers by 8. GPT-5 Mini follows the same pattern, moving from roughly 53% to about 60%. Alright, Figure 4 showed that wider rollouts improve success. Table 2 presents how the upgraded base agent changes both accuracy and efficiency. Agent S3 reaches about 63% 100-step success, roughly 14 points higher than Agent S2, while cutting language model calls per task by about 52%. The average task time falls from around 2,367 seconds to about 891 seconds, which is a 62% reduction. The non-hierarchical Agent S2 helped, and Agent S3 pushes both speed and reliability further. So, Table 2 focused on efficiency gains. Table 6 reports transfer to WindowsAgentArena. The table shows UI TARS 1.5 at 42% for 50 steps. Agent S3 with GPT-5 reaches 49% at 50 steps and 50% at 100. Behavior best of N with 3 rollouts in GPT-5 climbs to 54% at 50 steps and 57% at 100, which is an improvement of about 6 points over Agent S3. 2 takeaways stand out. Scaling by generating many trajectories and judging behavior narratives reliably lifts success to about 70% on OSWorld, and the upgraded Agent S3 makes this practical by cutting calls and time. The broader implication is clear. Structured trajectory understanding unlocks robust, cross-platform computer use automation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.